Sedimentary rocks. These are quite a few, if not almost the majority of the surface rocks in New York State, because of what New York State used to be covered over a long time ago with an ocean and different lakes and all that stuff. So, how are sedimentary rocks formed? They are formed from the accumulation of sediments, and it undergoes lithification. Lithification basically is a fancy word for saying it was somehow like cemented or compressed together, okay? And how you get the accumulation of sediments a lot of times can come from there was water there and there were sediments floating around in it, and they eventually settled down. Other sediments were laid on top of it over and over and over again. The water wears away, lots of pressure, lithification happens, boom, sedimentary rock, okay? So sediments, this is the definition of it, are tiny rock particles that are weathered away from or broken off from other rocks of, it can either be rocks or it can also be organic material. It can be plants, it can be animals, it can be dinosaurs, it could be anything, fish, it could have been shells, stuff like that, okay? So this is actually a really cool sedimentary looking rock because you can actually see different layers of different sized particles, different sized sediments that were then compressed and lithified together. Okay, so you can see like the sand or clay or silt in different areas, and then you can see that there's larger rocks that had been laid down at different times. Okay, so this chart is on page 7 of your reference tables that you need to have out and in front of you. I'm talking about this scheme for sedimentary rock identification chart. This is the top chart on page 7. This is the only chart that I will be talking about right now in this sedimentary rock note packet or note section, okay? You can see there's inorganic land-derived sedimentary rocks. So this top part up here means that they are clastic. I'm gonna go over what clastic means, but you can see that it goes by increasing grain size, or decreasing grain size, I'm sorry. The biggest grain pieces are up top, the smaller ones are down here. You can tell the composition. You can see the comments about the size of the fragments or what's going on inside. You have the rock name, and then later on in another one of our units, you're gonna need to know the map symbols. So this you'll be able to refer back to. Then you have your chemically and or organically formed sedimentary rocks. You have crystalline. I'll explain what that means later. Crystalline or bioclastic, and then you have bioclastic. Bioclastic means it was made from something that was once living. Grain size, you can read there to see what it says. The composition, so what minerals is it made up of from? You have comments of different things that it tells you where they're precipitates of, or they were compacted plant remains. And then you have the rock name and again, the map symbols. So where do sedimentary rocks form? The majority of them form at the bottom of large bodies of water. So what happens is, I told you that you have a big body of water there, sediments floating around, those sediments eventually start to settle, okay? And then there's sediments that are laid up on top of them, compresses everything together, makes a sedimentary rock. Another way is that you have microscopic, teeny tiny pieces of different minerals that are floating around in the water. When the water starts to evaporate away, it's going to leave behind those pieces of minerals. Those are called precipitates or evaporites, and they start to build up after a while. And once all the water is gone, it leaves behind all of those, which they then make almost like a crystal. So where are sedimentary rocks formed or found? They're usually found towards the top layers of the earth because they're formed at the surface of the earth. They're usually not found very deep because also once they get too deep, there's too much pressure. It changes the crystal structure of it and it can make it into a metamorphic rock and it's no longer sedimentary. Sedimentary rocks can also be found at the bottom of lakes and oceans, and then what happens is at the bottoms of those lakes and oceans, if something pushes it upward somehow, like you have mountain building where there's two continents crashing into each other, or you have magma that's bubbling up underneath and it's causing that layer to push itself up, that's where also you can find sedimentary rocks being pushed up. So, texture of sedimentary rocks. Clastic basically means that individual rock fragments were bonded together somehow. So you're going to have sand pieces that are bonded together. That makes a sandstone. You have clay that can get bonded together. That makes a different type of rock. Okay, so it's through cementation or compaction. And which rocks are clastic? You have conglomerate, breccia, sandstone, siltstone, and shale. Conglomerate has rounded fragments in it. It almost looks like somebody took a big bag of mixed rocks and cemented them all together, and you got conglomerate. Breccia almost looks very similar to it, but breccia has angular fragments in it. You have your sandstone, siltstone, and shale is made from clay. Siltstone's made from silt. Okay, so remember that clastic is pieces of rocks bonded together. So if something is crystalline, it's being composed of crystals. So you have evaporites or precipitates. Rock salt, rock gypsum, dolostone, and limestone are all crystalline. They're made from the water either evaporating away and leaving behind something, or the fact that there's so much of those minerals in the water that they then start sticking together and they make a precipitate. Okay, so bioclastic is formed from the remains of living organisms, and it can be biological and limestone. Limestone sometimes is made from shells that were all compressed together and cemented together. And it looks like Rice Krispie treats, that they're shells that have all been cemented together. Okay. Coal is also bioclastic as well. Lots of places that used to be swampy, and there were lots of plants that all died in the same area, and then animals and so on and so forth. That was all compressed together, and that can make coal. So lithification, I told you, was like a fancy way of saying that it was cemented or compacted together. So it's the process by which accumulation of sediment turns into a solid mass or a sedimentary rock. So basically you have your loose pieces of rock, they get lithified, there was lithification that happens, they get pushed together, makes a sedimentary rock. Well, bam. So there's 4 main processes of lithification. You can have cementation, which is when substances like calcium, a calcium carbonate, binds them together. Calcium carbonate kind of acts like a glue, and it allows for things to kind of stick together, and they stay together pretty hard too. There's also compression and compaction. So pressure being pushed down on these different layers can actually cause them to stick together, and it does form a rock. A lot of times with these strata pieces, that the layers on top are actually compressing the layers underneath it a lot more, making it a harder rock. There's a chemical process, what I was telling you before. Precipitation is the separation of solid particles out of solution. This can make stalagmites and stalactites in limestone. So there's water. Water has stuff inside of it. Unless it's distilled, distilled water usually has no impurities in it, but water that you get from the tap, or you get it from the ground, or you get it from the lake, or you get it from the river, there's stuff inside of it. There's minerals, there's sometimes biological things if you get it from the river. Hopefully there's no biological things coming out of tap water. That would be bad. But those minerals inside of it, sometimes there's so many minerals inside of it that they start to kind of collect together, especially if the water is standing still and those minerals have time to get together and they kind of start precipitating together. This happens too if you have ever been to Howe Caverns. The water can travel through rock. It takes a really long time, but water does come through rock. And when it does come through it, it drips down, say like in Howe Caverns on the other side, it's precipitating the minerals inside the water and it's leaving them behind, and it creates those stalagmites and the stalactites. Stalactites hang from the ceiling. Stalagmites grow mighty from the ground. That's how I remember. Okay, and then you have evaporites. So this is when all of the water evaporates away and you leave like salt behind to bind together. So like rock salt is made this way. If you've ever boiled something and you had a lot of salt in the water and then you like just turned it off and you notice there might be like a salt ring around the top of your pot, that is basically like what an evaporite would be. There was so much of that mineral inside of the water that when the water started to evaporate away, it leaves behind the minerals inside of it. So this is how rock salt and rock gypsum is made, because the gypsum will start to evaporate, or when the water evaporates away, it will get together and it makes a rock. So these are precipitates, your stalagmites and stalactites. Evaporites, where you have this lake of water and now the water is all evaporating away and it's leaving behind all of the evaporate. Now we have living organisms. This biological remains of plants and animals cemented together by dissolved minerals or squished together. So limestone can be made from just calcite being smushed together, or it can be made of those shells. The shells of once living things can be compressed together. There's different types of limestone. There's chemical and then there's the biological. And then you have coal. Okay, so fossils, which are the remains of or impressions of any other evidence of plants and animals. Fossils can only be found in sedimentary rocks because an igneous rock has to be made from molten stuff. Do you think a fossil's going to survive being melted? No. And metamorphic rocks, which we haven't really talked about, those are going to distort fossils too much that they're not going to be preserved. So really the only type of rock that you can find fossils in are these sedimentary rocks. Okay. So this is the different coal deposits around the United States that you can see. There are quite a few in like the Pennsylvania area. They are mining that and they do use that quite a bit because there are still quite a few coal plants. And over in the Dakotas and those areas. So fossils, how they're formed. I'm not going to read the whole things. You guys can go through them if you want, but you have your animal. This, in fact, is a trilobite. Trilobites are really cool. They're one of my favorite once living thing. They're a fossil now. Trilobite dies. The skeleton is intact. Sediments get laid on top of it. More sediments get laid on top of it. So what's happening to this fossil is a couple things. It's either leaving an impression in the rock, meaning that the fossil shape is leaving like a mold in the rock. Or this also can be happening that the minerals like calcium and there's different, the quartz crystals can get in there, all that kinds of stuff. So what happens is that those minerals are taking the place of the actual shell. So when a fossil is made, it's actually not really the animal bones or not really the animal anymore. It's the minerals that have taken the place and have taken the shape of the actual animal. Okay? And over time, there's uplift that's going to happen. Weathering and erosion exposes more of the rock around it, and so that's how we sometimes are able to find fossils. So what's the only kind of rock fossils can be found in? I told you, it's sedimentary rocks. Why? Igneous, it won't survive. Metamorphic, it won't survive. It'll get too distorted for metamorphic, and igneous, it's going to melt it, and it won't show up. It'll get ruined. Okay? This is one of my favorites. These are trilobites. These are pretty cool. There are places in New York State you can go find trilobites. In fact, out towards Buffalo, there's a place called Penn-Dixie that you can go and you can actually mine and dig out trilobites of your own, which is kind of cool. There is also another place up near Plattsburgh. There's a place in Lake Champlain called Trilobite Island that you can go, and there's trilobites all over that island. So this chart again, clastic. Now you know what clastic means. It means that those fragments were cemented together. The grain size, these are bigger. It gets down to smaller. What it's made up of, so the composition. The type of comments, so conglomerate is made up of rounded fragments. Breccia is made up of angular fragments. Sandstone is fine to coarse. Siltstone is very fine. Shale is compact, may split easily. Okay, and then you have your chemically formed ones, where your crystallines are going to be your evaporites or precipitates. It's going to leave behind, or the water all disappears and leaves behind the minerals to form these different rocks. You have rock salt, rock gypsum, and dolostone. And then you have your bioclastic ones that they are varied in size. Most of these are varied in size, grain size. The different types of composition that they're made up of. And then the comments, so coal is made up of carbon because it's from plant remains, because living things have carbon in them. And then the limestone can be either chemical limestone made from precipitates and evaporites or biological origin. So it can actually be made of those shells. Okay, so this is the sedimentary rock chart. And then you're gonna have your own questions, and that's not your homework, so don't worry about that. Okay, page 7 of your reference tables, make sure you go over that and understand how this chart works. Good job.